screen?
Yeah, I can see it.
Okay, good. What I'll do is I think we got the software all installed from memory on the system. So you should be in this. You should basically be ready to go. I'll just show you the basic uh, system, how it how it operates from for the main part from A to Z. So
All
when
right.
you start the software, you've got your toolbar at the top here. You can also have a workspace that's visible, which may be stationary. You can actually right click this and say auto hide, or just leave it, leave it always visible. So I tend to have mine auto hide, but you don't have to.
All right.
Okay, because just give you a bit more space. Um,
Yeah.
and then in there is where you'll see the solid models component parts inside this workspace when you import a file. Otherwise, with regard to how the view works, how the viewing works, I'll show you that. I'll just open up a solid model so we've got something to um, to work with. I can just go to a Cad import
Okay.
and I can pick any of these. I've got a box I'm going to use here. Okay, so you can import a Parasolid, you can import an IGES file, 3D IGES. There are options available for other CAD systems if you want them. I think they're an option you can get from Germany. Step and Pro Engineer and all kind of things if you want, they're available. But I've just brought the box in anyway, so you can now see the way the cursor works is in the middle of the screen. If you drag your mouse, you get a rotation effect. Okay, if you go to the left a little bit, you get a zoom. If you go to the far left, you get a pan, and the same applies on the right side as well. So just remember that wherever you drag your mouse depends on what effect you're going to get. So depends on the kind of zones in the screen, the viewing area. You can also use the wheel of the mouse to to zoom in and out as well at any time.
Okay.
Now, sometimes you need to manipulate the view in the middle of a command. Say, if I had, for instance, something inside of here, I wanted to delete. I can't, and I was in this position. The box was in this position. I wouldn't be able to see the thing behind the box. So what you can do is when you're in a command, any command which means there's a prompt on the screen, you can keep the shift key down, and then while the shift key is down, you can move the viewer out. So for instance, if I went to delete an item, this is icon up here, and I wanted to delete something that's on the other side of the box. I've got the prompt saying, please select the items, press enter when done. It's down the bottom of the screen too in green, so you can see that. If I wanted to move the view, I could click the shift key down, and you'll notice my cursor changes again. I can then rotate the view around, and as soon as I let my shift key up, I'm back in the command asking me what to delete. So just remember to keep the shift key down if you need to move the display, the view, in the middle of a command. It's just simple as that. It's just shift key.
Okay.
And
So shift temporarily disables the command.
Yeah, just takes it out of the command temporarily so you can move your view. So that's how that works. Press escape to come out of this command, or I can press the red check, or the green check actually ends the command. When you're doing commands, you can use the enter key most of the time to press to come out of the command, or you can click the green check, or you can right click and say end the command. So it's the three ways to do the same thing. So I was going to escape out of this. Okay. The other thing is how you select things. So if I'm just going to make some copies of this box for the sake of it. Example, translate and copy. So it's asking me to select the items. I'm going to say pick this box, and then I could pick another one, but there isn't another one. So I can just press enter, or I can press the green check. A number of copies 3, And then from position, I'll just say it's from, I don't know, midpoint of there to, I don't know, let's say X6. So in the software, you always use X and Y and Z if you want to put a coordinate in. So X6, Y0, whatever. I just press enter. Okay, not far enough apart, so let me undo that. Undo. Translate and copy. Make them like 20 inches. Number of copies 3. From the center, so the midpoint of this, I'll explain those in a little bit. I'll just go X20. Alright, so I've got 4 boxes now. When you want to delete something or select some multiple things, you can use, for instance, I wanted to delete this. I could say delete. And I could pick these boxes individually, of course, right? The other way I could do it is I could just window them. So if I do this window, it will get the 2 center ones, but it won't get the 2 outside ones because they weren't inside the box, right? If I do it another way, if I go the opposite way out, if I go from the top right to the bottom left, as long as it touches, it's inside or touch one of those lines touches the box, it will select them. So I tend to use, be multiple selecting. You either want to use, the window one, or the back inside out window where the corners cross over. So that's how we can do multiple selections. I could do those 2 with an inside out window, and I could just pick these 2 individually, and it says at the bottom of the screen I've got 4 items selected in total. And once I'm okay with that, I can then just press the enter key or the green check, and it does it. All right. So that's how the selection works. I'm going to show you one thing about the snapping modes too. So these are our common commands here. You don't zoom in, make it fit to the screen, all that good stuff. Redraw the screen, undo, redo. And you can also, change the colors of the solids, or see them translucent or not. And you can also do, give me an XY view, give me a XZ view, etc. These buttons will change though when you're in the middle of a command. So if I say copy translate again, you'll notice they've changed. Okay. So the commands that are appropriate for this function, copy translator here, you've got the ability to link something. If it was lines and arcs, you could just chain them together. You've got the ability to mask things. So you could go here and say, I only want to, I want to pick only red things or green things or lines or arcs, or I only want to pick solid bodies. So you can do that here. It's just a way of filtering entities and, colors, etc. So you have, there's the main ones you've got. So I'm going to pick the part, and I press enter, and then it says number of copies. I'll say 1. Now when it says where you're gonna copy it from, I can pick the midpoint of something if I want. You notice my view is in the XZ view. So I want it to be really in the more of an isometric view. So I can kick the shift key down and I can move my view around so I can, pick. Now I've got a proper, I can see the cursor crosshairs properly. These are the snapping view. This is a snapping method. So there's an end of, intersection, a midpoint, center of, normal to, quadrant, automatic, and then there's a coordinate one. So when you're in automatic mode, it snaps to the most obvious thing it thinks you should be trying to pick. So it's now snapping to the midpoint. If I go to like the circle, I'm on the outside. If I'm more on the inside of the circle, it'll get the center. If I'm more on the outside, it may get the end of or the quadrant of, right? So these are the snap modes. You can use automatic, or if you wanted specifically, say, the end of here, you could right click and say end of. And that will, for that one pick only, use end of, okay? But it will still remain in automatic mode for the rest of the picks, all right? You could also, you could actually press this in, and then it will only pick end of. It won't pick any midpoints. It'll just be end of mode, full stop. It won't change from automatic. It only does end ofs. So these are the kind of modal, the overriding snap mode. And then you can change it to just for one click. You can force it to say, end of or center of or whatever. Okay, so they're pretty simple enough. So again, like I say, I want to, I want it to go from here, the end of there, to the end of there, of course, and it will just, join, basically made a copy that's touching the other end.
Yeah.
So snapping is just done there. If I delete this again, I can just delete this box, press the enter key, press the green check, and that's it. You also have a little function here to do 4 views, so you could say give me 4 views, and I say fit. It's you should see. Just remove this. Okay, you can see the effect of that. You can drag this around to see in 4 views, and you can say if you want to change to one of the views, you can just click that 4 toggle between 4 single viewports. Just pick it, and it says select the viewport. Just pick the isometric if you want, and you're back to single view. So that's really the whistle stop, which is how the kind of picking interface works, and how you use snap modes and things like that, and how you can rotate the view in the middle of a command with the shift key. That's all there. And also how you would do, when you want to specify a position, you specify it with X, Y, and Z, or one of them. I'll show you one other thing about that, which is quite useful when you're inserting clamps. Is everything's kind of absolute, right? So if I made a copy of this one, again, copy translate, and said one of those, clicked it, press the enter key, number of copies 1. So when you see the prompt in less than and greater than symbols, that's the default. You just press enter. So I didn't bother typing in 1. I'll do it again. Translate copy, pick the part. When it says 1 here, if I just press enter, that's going to give me 1. It's a default.
Okay.
From position, I could say, well, okay, it's from here, the end of there. And if I didn't know where the absolute position is, I want to send it, but I know I need to move it 30 inches. I could say dx30, and if I want to move it up, say 6 inches in y from where it is, I could say dy6, and I could say dz -2 or something, right? So this is going to incrementally move it from that pick to those, shift it over by those values, right? So if I do that, you'll see it's kind of moved it over and down and up. So if I go, it should be, it's down in space, right? So it's basically a way of shifting something, is to shift it by a value. You say dx, dy, or dz. That's how you do incremental shifts in the software. Other than that, a lot of these menus you don't really need. The construction menu I can't see you ever using. It's if you want to draw your own geometry using construction items, which is kind of an older CAM system way of doing it. You've got drawing. You don't probably want to draw anything. You can. It's something we don't teach, but there are sources online we could get you if you wanted to learn to draw. But it's not really designed for this purpose of the Nucleo fixture is to make fixtures from an existing solid model. So, but if you do get into line drawing, it's just like AutoCAD really. I could say draw and then specify my start point x0, y0. You can say go to x, go to y20. And you can do typical thing. I could say dx10. And it'll go across 10 inches, dy -2, so it's kind of typical AutoCAD type drawing. So you can switch to arc mode, press A. I could say that the end of that is dx10, right? So you can draw whatever you want, but it's not something you need to really know too much about. So let me delete this. I just went to delete, and I can actually show you how you can chain it. I could just say chain, pick the first one, and it will chain all the other bits. And I can press enter. Right. So drawing, not very often. There are cases where you may extrude something. For instance, if I wanted to make a special shape to constrain the height of the fixture, I could do that by drawing a boundary and making a user-defined shape. I mean, what it would do is, if I wanted to say control, make a kind of, if I had a very formed part that was, I wanted to maintain a kind of nice fluid top surface, I could draw a sheet that is basically, a rough kind of a sketch over the top of it, like as if you were sticking a blanket over the top of a part, a kind of blanket that kind of fits the form of the top of the fixture. You could use line art draw there to then create a section of the shape you want, and then you could just extrude it, and that would make us a sheet body that's kind of, whatever shape you did. It's like a section, you're creating a section and then extruding it along the section. But again, it's on the website if you want to get into that stuff. It's a bit more advanced, but that's the only time I can see you really wanting to draw something and use extrude. So
Yeah.
let's go to modify.
All right.
Modify is just modifying basically lines and arc mostly. So you don't generally do that. If you want to put blends or break intersections or trim something back, 2D geometry, you can do that. Convert entities sometimes is used. You want to convert solid edges or loops into lines and arcs, or vice versa. You can use that, but not very often used. Edit 3D geometry. Again, you're not really drawing in the software, so there's no reason really to use this. The only one I use now and then is this cover holes and gaps. So
Okay.
if we look at the bottom of this box, it's got holes in it. Say you wanted to not have your fixture potentially poke up through those holes. If you put a blade through there, it could potentially poke up through the hole. What you could do is say cover holes and gaps, and you could pick the face, right? Press the Enter key, and then say cover, and then it's covered it with a sheet. So now you're stopping, you've blocked it off really. And you'll see in the workspace I've got a sheet here, which is doing that. So that's one thing you can do, cover holes and gaps, but that's about it really.
Yeah.
Other than that, viewing is pretty simple stuff. All the viewing really is done up here these days, so you don't need to worry about it. Information you can check and measure. Check and measure is easy, it's quite useful. You can say what's the distance between, say, the midpoint of there and the midpoint of there, and it tells you it's 15 inches, and then it's good, in X, delta distance, but also because it's in line, it's the same value. The distance is the same, so you can get.
And that snaps automatically too.
Sorry.
And that automatically snaps as well.
It did. I snapped the midpoint. Yeah. So I could go right from the center of there to the, center of there, and that's the distance is 15, but the delta X, delta Y, and delta Z are obviously, different. Just a way to get a quick number of what distance is, between something or a dimension.
Yeah.
Layers and figures you don't use really, but inside the software when we create the fixture and we create the all the parts, they do go on layers. They're like a layer for the blades, a layer for the base plate, a layer for the imported part you brought in. So you can get into layer maintenance, clicking this button here. You can hide the ones or hide the ones you don't want to see. You can also do it via a shortcut. You can double click this layer pane down the bottom of the screen, and basically you can do it that way. It's double clicking it, it's a shortcut. While I'm here, you can also double click this pane here, colors and line styles, and that will give us a system settings where you can change things like colors. If you don't like your background color, you can change it here. If you prefer your view to be just solid without wireframe on the outside, I could do that, and you'll see what will change. Like apply it, you can see it's lost the kind of edges of the lines now. So the edges aren't highlighted. If you prefer that, you can just go back into there, double click that, say view, and say I rather have wire and solid, and you can apply that. You'll see the lines come back. You also want to make sure you've got your rotation mode to free rotation, which I think it defaults to, but for the milling and turning, we tend to say to keep the z-axis upright, but for this we want it to be free. The other thing is you know, there's not much really you can change some things here. One thing I wanted to tell you while we're thinking about viewing, if I wanted to move this around, and if I was zoomed in on my wheel over here, and I move it around, it's jumping too much. I don't like the view is too jumpy. That makes sense?
Yeah.
What you can do is you can say, okay, you can reset your rotate around point by just right clicking and say set view rotate point. You pick something like the end of this. All right. Now when I move it, it's smooth around that point. So if you ever zoom right in, you start rotating, and it's jumping around too much, you just got to reset your view. Right click, set rotate point, pick somewhere, something snappable, and then you're good. All right. There's also ways you can hide solids and that. You could say, okay, this is in the way. You could just right click on it, and you could say box hide body. Yeah, and it's disappeared. You'll see it in the workspace as kind of got a cross through here. Anytime you want to show it, you can just right click and say show all hidden bodies, and it'll come back. This is useful when you've got a boundary. You put a boundary on it to control the Z height, and it's in the way, it's annoying you. You can just right click and say hide it. You can also do it though by turning its layer on and off. So the boundaries and the blades are on their own layers, so you can turn those layers on and off. But of course, if you actually physically hide the solid, even if the layer's on, it will still be hidden. So you can always look in the workspace to see what the status of any of the solids are, whether they're hidden or not. Basically on the transformation menu, it's typical what we were doing before. Basically, copy translate something. You might need to do two steps on a fixture. You might have to do some tack welding on one part of the fixture, and then you might want to move it to a second station and do the rest of the welding. So it might be you want to copy or duplicate the solid bits, the parts, so you can remove the ones you don't want in the first step because they're subsequent to the second operation. So you can use copy translate to do that before you start doing the fixture design, as it were. But that's really it. You can mirror stuff here. You can translate scale stuff, whatever you want to do. Okay. Then obviously our main work's all done on the fixture menu. So we would do, you can set your measurement system by default, and you can set it to inch or imperial, we call it here, and just say don't show this on startup, and it will always start in inch. And if you want to change it to metric, you just go and change it that one time. You'll notice the rulers down the side of the screen change to metric or inch. So if I go to metric, you've got millimeter scale now.
Okay.
I'll go back to it. So it might be that this comes up every time you do a new program. If it gets on your nerves, you just uncheck this box and then you're good. These options, like I go through quickly. Color solid by layer type. That is a special function we wrote just for a customer who was overlaying trailers on top of each other. He'd have a 10-foot, 12-foot, and a 16-foot trailer. So he'd import the parts for a 10-foot trailer. Then this would then go and color all those parts red. And then he'd import the 10-foot trailer, the 12-foot trailer. It will color all those parts green. And so they're on top of each other, so you can see where the 12-foot and the 10-foot trailer stopped. Where the common places were for some of the elements were the same. But as you can imagine, it was getting longer in one direction. So it's a very special option. No one ever probably uses it, to be honest, outside of those guys. Locate part model. It just lets you get the part in the right place before you start the wizard. If you don't locate the part first, it will ask you to do it inside the wizard. The reason it's here as a separate pick is that some people prefer to get their part in the correct place, which is X0, Y0, Z2 or something like this. Then they want to maybe draw some lines, just freehand sketch some lines in where they want to put their blades. And then later on in the wizard itself, they could say, use these existing lines I've drawn. Clearly, if you haven't got the part in the right place, though, and you start drawing the lines, the software is going to move the part to the right position, and your lines are still left behind. So it's a way of getting the part in the right place, doing those lines freehand, and then having them in the right place. Most people, though, do the lines, do the actual positioning of the part in the wizard, and the lines are drawn in the wizard. But it's just an option. That's why we've got the option to add lines here outside of the wizard, so you can locate it, add your own lines or whatever, and then run the wizard. The wizard is just the way we start the process. When you do a new fixture, you start that. You follow the prompts. The editor is just a way to edit an existing one where you've gone through the wizard already and saved the program or the part, and you want to go back and edit it. And say add lines makes you want to lets you add lines to the drawing outside of the wizard. Blade properties is something new we're working on actually, which will let you set an individual blade to have its own properties. Right now, all the blades have the same properties. Say if they've got bumps on, or they've got a certain offset, or they've got holes in them, it applies to every blade in the drawing. This option is going to let, which I'm working on actually, will allow you to say on this blade I want a different offset, or on this blade I want holes in it, or something, different things. Right now it just lets you, move the lines interactively. The end smart boundaries is a new option I'm working on that allows you to control the height of the fixtures, the blades independently, just with a boundary which you can move up and down. It's brand new actually, so I'm going to we're testing it a little internally, but it's just a new way of controlling the Z height, which we can get to another time. Direct start, start and end. Once you've got a fixture made, you can say, I want to edit that component of the fixture. I want to edit the base plate, or I want to edit the blades. So you can then just pick the blade. It lays it down in 2D flat for you, and it turns it into lines and arcs. You can then use the modify and the line art draw stuff to change the shape of the blade. And once you've finished with all that, you can just say end, and it puts it back. It puts it back as a solid model. So it's a direct editing function that you can do at the end of creating your fixture. If you want to do some discrete changes, you can do that there. All right. But of course, if you rebuild the fixture, they will be erased. So it's the kind of thing you do once you're happy with your result. Visibility, just as I said, things go on different layers. So you can show the fixture layer, the part layer, the boundaries, and etc., the clamps and all sorts of stuff. You can also make the part transparent, and there's all sorts of things you can do there. Build preview is a quicker representation of the fixture, but not much quicker. I don't tend to use it. You can't guarantee, because it doesn't do such a mathematically tight calculation, you might not get what you expect. So it's a good quick check, but build final is a way to do the final fixture. And then once you have your fixture complete, you can make the CAD files for it, the DXF files. You can make a Parasolid file automatically, or you can use a button next to this, an STL file, which is a 3D printed type thing, just so you can view it on anybody's computer for free. And also it creates a bill of materials and all that stuff. And lastly, we got direct edits, which is a little bit like these two over here. Just lets you put on discrete things on the edge of a blade, or put a hole in the blade or the base plate interactively. Just another way to change the geometry. And finally, Nucleo, the options, has got things where at the end of the dialogue, at the end of the process, it may give you a message of, is everything okay? If that gets on your nerves after the first 10 times, you can do not show completion dialogue. You can turn that off. There's other things you can adjust here for where what the wizard looks like. Say the icons don't fit, you can give some offsets here to make the icons fit better. And then we've got things like Cad Export Options, where you can say, when I export my CAD files to DXF, I want my geometry on a layer called geometry, my text annotation, and I want it in red, green, or cyan, whatever I prefer. And you can also create, as I say, you can create include a Parasolid and include STLs, etc. as well. So that's a brief of all those. But the process of using it would be from start to finish on an average day. We just start with a new program, and we go to File, CAD Import. Okay, we pick our part, Now what I'm going to do before I do that, I go to import parameters, and I'm going to say make sure this button's checked. Use CAD file name. So you want to do that the first time. Once you do it the first time, it will always be set. Now in this newer version I've got, there's this explode assemblies option. You won't have that, but I'll explain what that means in a minute. So you just check that checkbox, and then you can open up the file. So box, I got a box Parasite XT, the same one, and then open. Now that checkbox that says use CAD file name, what it does, instead of this being called Untitled, it's now going to be called box. It's called my job, my fixture drawing file inside a Nucleo. It's already called it box, so it inherits the name of the CAD file. So it's a good idea, right, to have that, so you know it's. So when you save the part in Nucleo, it'll create a file called box.vdm. So our file extension is a VDM file. So that's just that just does that. It just names it for you. Once it's come in, if you've got a part coming in from some other CAD system, you'll see solid models here. You may see, like, bits and pieces, nuts, bolts, and all sorts of stuff. You may also see assemblies, and they will look like little blue assembly icons in here. You have to explode them, so you have to right click and explode them. But there's, if you have them, you explode them. The quickest way is to do it actually in the viewing workspace. So if this was an assembly, you can just right click on it. You'll see an assembly in the list. It'll say Assemb1 or something. You can just go across and say explode, and it will try to explode it itself and any sub assemblies inside it. But that's what that option does on the CAD import. It does it for you automatically in this version, but this one isn't released yet. So you just have to make sure you right click on it and say, if it's an assembly, you need to explode it. If you don't do that and you start doing the fixture, you might see all sorts of strange things happening, so you have to explode it. So once you've got your part in here, you would normally go straight to the wizard. So go to the wizard, and the first step is, I want to see what's going on here. You can press this little image helper, and it will come up with a little picture. This one hasn't got any help actually, but I talked earlier about sometimes if your icons get chopped off, you can change one of the values in the options dialog here to give it more width. If they are chopped off, you can just change the option was this one here, pixel adjustment. So if I wanted it to be a bit bigger, I could say, I want 50, and it will. When I go back in the wizard, you'll see it's even got a bit more meat on it, a bit more meat on the. Yeah, it's got more of a width here. So that's how you can adjust that. But these are basically your, common icons, X, Y view and all that stuff. Fit the screen, wireframe, hide the fixture, hide the part, hide the boundaries, or toggle them on and off, repaint. And then this button, if you see this will just reset any of the values on this page to the standard defaults. So if you mess them up, you can always change them. The first thing you can do here is change the transparency. So I might say I want it, about that. I press the green check. We can have it really transparent. In this case, we just need to get our part located the right way. It's 90 degrees out of position. So you could do two things. You could just say rotate it 90 and press the green check next to it, and it'll rotate it. Okay. You could also, if it came in at some funky angle, right? I could say align to face. So click align to face. I can pick the inside face here, right?
Yeah.
It then says pick the bodies. So I might have 20 bodies. So I'm going to the window, outside window, everything. So I've got all my bodies. I've only got one in this case, but if I had lots of them, I want to line them all up. So I pick them all, press the green checkbox, and then I want to say I want to datum it. Well, I want to make it XY planar rather, right? I want to keep that face upright. If I don't check that, the box it'll be the other way up. The box won't have, it'll be like I'll be fixturing the convex side of the box. So if I uncheck that, it will actually make it the right way up for me. No, I was wrong. So I must have got that wrong. So let me do it again. Line to face. This time, this face, this part. Press enter. I don't want it upright. Right. So now I've got my box nicely aligned to XY. and it's probably a little bit high up in the air. So if I just say center it, it just puts it down at a nice X0, Y0, Z2 position, which is the default pattern. Okay. You then go to the next step. Next step is just your material. So you can choose from, standard gauge materials, 11 gauge, for instance, and it gives you the nominal thickness of 11 gauge. You have to get these numbers on the nail somewhat so the thing goes together correctly, right? So if you find you've got a slop in the fixture, you've obviously got your material to thinly set in here. If you can't get the thing together, the material's thicker than what is in here. So it's kind of important. Then you can also put some clearance in the slots. So the picture tells it really, A and B, then C is this one. It's basically 4 thousandths will mean there's a 2 thou gap each side of this material, if you want to. You can also add your own templates. You could create your own templates, call it my favorite, 11 gauge, save. And you can type all these things in, all these values, these offsets and tolerances, and then you can just you can use that one in the future. The other one, I think I put a name on it. Yeah, okay. I thought I changed the name. Let me do that. Right. So you can do that. Save your own favorites of material parameters, basically. Right. So the other one on here is this material thickness here. It's not very important, but it just helps the software sometimes use better parameters to create the fixture. If you can imagine, this wasn't bent over, this wasn't formed, so all we had was this material thickness here. Yeah, and if you imagine the box was upside down, so this was Z, basically 180 degrees around the X. The thinnest material you'd see in the model would be this gauge material. So you could type in there whatever gauge material that is. It just gives it you don't have to do it. It just helps to choose some parameters sometimes. It's just a helper really. But if you imagine if you imagine a U shape, which is upside down, just a bent U, but you turned upside down, the thinnest material that you'd encounter would be whatever that material was made, that part was made of, 11 gauge or 7 gauge, whatever. But not to worry about too much anyway. Then you've got next step. You've got how much you want to basically encapsulate the part. You want it to go, say, 2 inches bigger in X, 2 inches bigger in Y, and 1 inch high up the edges. So it will zip up the edges of these box by 1 inch. You don't have to pay too much attention to this. It's just a starting number. So when you place the lines on the fixture for where the blades are going to go, it knows how long to make them bigger than the box. The stuff that goes at the side, the 1 inch up the side, I tend to override that with a boundary, which I'll show you in a minute. You don't have to put boundaries on the part, but I find you get a result that you kind of more expect. So I always draw boundaries on my parts. This is just a base plate, so you want to make the base plate, say 4 inches bigger than the extent of the blades, basically. The corner radius on the corners, a chamfer on the bottom left. You can make the fixture base plate a given size, 18 by 24. This might be useful if you've got a rotary or a head and tail stock and you need to clamp this base plate or this part to the picture frame that goes around the rotary axis. So you can make it a given size. You can also use a template where you've drawn one already. You can draw your own, sketch your own. You can do your own weld table. You can also use parametric base plates. So you could go here and say you had a blue coat table. You just wanted to use a blue coat table. You can just type in the values of the pitch of the holes in the blue coat table and just use that one over and over again. So it's a way you can make a library of standard base plates or use a blue coat table, etc.
Okay.
Right. So I'm just going to go with 4 inches bigger and the values here defaulted. Then I go next. Right. So here is where we can draw our boundaries. You can draw all sorts of different types. line arcs, rectangle ones, triangle ones. Just think of them as limitations, basically. They limit the z height of the boundary. My most popular one is envelope. So I want to make a boundary that envelops this part or these parts by 2.5 inches, right? So I just say create boundary. I pick the parts I want to envelop. So there's only one, but there could be two, right? I could keep picking, and I press the enter key, the green key, and it's drawn me the boundary, and I can then move that up and down half-inch steps to the position I like. I can even tilt them, mirror them, scale them. I can do all sorts. So just think about basically instead of it stopping 1 inch up the side, the fixture is going to hit this boundary and stop instead.
Okay.
Now, by default, boundaries are considered as part of the fixture in respect to making the base plates. So I said to the software, make my base plate 4 inches bigger than my fixture, basically. What it does mean, it also makes it 4 inches bigger than the boundary. So in other words, if base plate looks too big and you don't want to consider it as part of the extents of the fixture, you can just turn it off with this bounding extents property. You can just pick the boundary and say, no, I don't want to consider this as something in the fixture that I want to use to calculate the base plate size. So it's just if you get a big base plate basically, and you can just try and turn off the association, tell it that boundary doesn't need to be considered as part of the calculation. That's where that is. Again, you can add as many as you like. You can draw your own. If you want to draw a rectangular one, you could just say rectangle, create bounding limit. Like I say, okay, it starts, the center of that and finishes over here. So this is asking me now, do you want to include it? Do you want to include this as part of the overall extents? I'll say no. So you see it's put it as Z0, so I can then move it up into the position I want, wherever I want it. So you can do that. I'm going to delete that one though, it's a silly one. So once you've got that done, you can go to the next step. This is just if you wanted to do a grid of these, you want to do multiple parts in one fixture, you can make a grid array of them. Number of columns, number of rows, gap in X, gap in Y. You type that in, you can say create grid, and in essence it makes a base plate bigger, and you just cut extra blades to fit in the base plate. Okay. This one is where you will change day to day, right? So some of these pages you don't often change the values, but this one you have to, because it's where the lines are going to be. So like I say, give me an automatic size, and it's drawn me 3.6 inches. I'm going to say, okay, I want them at 4 inches, and you can see it's drawn the lines. I'll hide the layer that contains the boundary now, so you can see it clearly. All right, put it back on again, and I'll tell you why in a minute. Right, so once you've got those in there, you can move them, shrink them, extend them. I'm going to try to move some of them. So I'm going to move this one. I'm going to press enter, and I'm going to move it 1/2 inch steps. I'm going to move it out 1 inch. I'm going to pick this one, and I'm going to move it across 1 inch. Now I'm going to shrink these so I can get in the corner. So I say shrink lines, select the lines. I'm just going to outside window. So I just touch those two, outside window, touch those two. All right, so I've got 4 things. And then I'm going to say shrink it. I'm going to say shrink it 2 inches. Minus X, plus X, minus Y, plus Y. I might do the minus X a bit more than the plus X. There you go. So I expose my corners, right? So I can get my my head in there to do it.
All right.
A little bit less on the Y as well. There you go. So you can do that. You don't have to do it on the outside of the box, but the benefit of the boundary in this case is that there's something for the blades to intersect with or to meet to. So the boundary is useful in this case. They're stop outside. I mean, I've seen many boxes like this one particularly where you don't need the external stiffeners, but just to show you that's one way of doing it, I've done that. The other way you can do it is you can select and arrange lines, which Sometimes it's good. You just say, give me like 8 in X, 8 in Y, and then you can just go in here and select and arrange. You just go around in a loop. You say, okay, this one, let's do this one. This one, I want to move to, say, the end of there, right? Then say this one, I want to move to mid end of there. So you go around in a circle, you know, looping around, just moving things to snap positions, right? Let's see, I can move those back again, somewhere more sensible. I was in the center, so I do a midpoint of this, yeah. And then this one, I'll just say is, I don't know, end of there. This one is the end of there. Sometimes, so that's, you can do that. You can also add your own line. So I could say, here I could say add me a line. There's several ways to do this. The main two were the main two first ones. You can do them with zones from existing lines, what I talked about before. If you just free-handed some lines in there, even if they weren't straight, you could use this option to pick those lines, and it would just straighten them up and use them. But I'll just show you the two obvious ones. I have my prompt for alignment point set, and I say fit to the extent. So I say create. So it says, what's your alignment point? Well, I want it to go through the center of this hole here, and what I want it to go horizontal. So I can just go click, click. Because it's going to the extents of the solids of the part, it knows how long to make it. So it's made it the same length as the others. So I'll do another one through the center of there, say, and I want to go from here to here, and it's just drawn it across the extents of the part. So press escape. I can undo that. All right. Make user defined lines. Same thing. Alignment point. I'll say, well, I want it to go through the end of this. Now, if I zoom in, sometimes you'll get this annoying thing happen where it snaps to the midpoint or something, and it could be that it's snapping to the midpoint of this face of this boundary. So this is a case where you'd either hide the layer. So you could, before you do this, you could just say hide the boundary, okay? Or you could do it when you create it. You could just go create, right click on the boundary and say hide, and then it's, you know, now it's going to snap to something in the box. It's not going to snap to the boundary. So so that's why you can do that. You could say then do from the end of there to my alignment point. I want to go, say, from the end of that to, say, I don't know, the center of midpoint of that. It's drawn a line that's gone from there to about here. You can't see it's underneath. So that's how you can do user defined lines that's, you know, at a given length. And then once you're finished, you could always right click in the background and say show all hidden bodies, and then the boundaries back. I just recommend, to be honest, just turning them off with the layer. Yeah. So you can create your own that way. So if you had a long part, like a long tubular part with flange at one end and flange at the other end, you don't need to put lines across the entire fixture. You can just put them around, you know, where you need it. So that's one way of doing it. You can change the blade thicknesses. You could say I want to do a 1/2 inch blade for some reason. It would then make that blade thicker. If you do change downstream the material size, you decide, oh, I'm going to use 11 gauge, I want to use 7 gauge. You have to go back to the second step, which was materials sizes. Type in whatever the value of the material is. Then you have to come back here and just make sure you set all the lines on the drawing to be the same thickness. So you would basically select all the lines, just with an outside window. You then type in the material thickness, which happens to be 1196 still, and then you click the green check, and it makes them 1196. If you don't do that, it'll still have the old material thickness in there, even though you've changed it. It could be that your guys ran out of 11 gauge, but you intended to use it, so now you've got to change the material. So you change it right back at the beginning. Go back. You change it here. And then you go back to the, then you also change it at the, you just select all your lines and you type in that new value and press the green checkbox. The other thing you can do here is also delete lines you don't want. I'm going to delete that silly one I just made. You can reverse the slot directions. We have the naming convention that we use is U and N. So U slots, N slots. Now the reason they're called that is because normally the purple ones are U's. They have slots that are U-shaped, and the green ones sit inside the purple ones with N-shaped slots. Used to be called vertical horizontal. Now the reason we changed that is because we've done some work on it, so some pre-release R&D stuff, where in the future we intend to be able to do lines at any angle. So they don't have to be at 90 degrees or orthogonal. They can be at, like a spider's web. In that case, sometimes you get blades that have got U slots and N slots on them. So we had to change the naming convention. So just think about them as U and N's, but in the future you might be able to have ones that are both U and N, which makes it, it's quite a challenge to put together sometimes, but we have done the research on that. You can invert the direction of those U and N, so you can make, instead of the purple ones being U-shape, you could invert them to be N's and the greens to be U's. That's not very advantageous. It makes it harder to build the fixture, but in some cases it means that the purple ones generally have the little feet that are locked to the base plate. It means the purple ones can keep the green ones clamped down to the base plate if that's what you choose to do. So it's just an option, but I don't recommend it very often. If you're turning the fixture upside down in a rotary axis, you should really just spot weld the fixture. Okay. Right. Then you've got the minimum distance that the fixture must reach. That means that if I didn't have a boundary and this line extended outside of this boundary and there was no solid body as it could see from underneath, it just means it must maintain a height of 1 inch. Okay. Well, this is the feet that go in the base plate. So you can have just a simple rectangle, which in that case you just make it, a certain size, 1.5 inches or whatever, and you want it 1 inch wide. No, sorry, 1.5 inch wide. You make it 1196 or something deep, right? So just fit in the base plate and be flush to the bottom of the plate. If you want to make a foot mechanism that locks together, you make that deeper, so like 1/2 inch. You can change the pitch, so how far away they are between each other, chamfer and all this stuff. And then you can then put in this case, you will put in how much the width, how wide this slot is, and how high the width, how high this is. The E dimension would of course be your base plate thickness. There's a few other little bits here, like this tooth, this F and G option, which is different customer. It just means that you have a tiny little extra height here. You might have like a 2/1000th of an inch distance. So it'll actually add. It will make this face would be 1196 minus 2000. So in this position it'll be 1196. In this position it'll be 1196. It'll be 1194, right? So it means that when they put the material in the base plate, the blade, it's got some resistance, and they have to tap it with a mallet, and it pings up through a mating hole in the base plate just for this tooth. So it's just another option we built in for people who want it. If you don't need it, you just put 0 in there. Okay, simple stuff. This is how you can do a clamps. Now in my version we've got some new stuff coming where you can working with Carl Lane, so you can actually download them, insert them, and it does a few things more automatically, but that's something you'll get. But you can insert your own parasolids. You have to prepare your own parasolid files, and there's some videos on the internet on how to do that, but here's one I've got, which is a Destaco. So I insert it, and then you just follow these commands: T for rotate, or R for T for translate, R for rotate. So I was going to say I want to snap it to their midpoint of that. Then I could say R, and I could say 180, 180. And then this is interesting. What I talked about earlier, distances and X's and Y and Z. You might want to translate it just to incrementally shift it. So you can say translate, T for translate, and I'll say DX2. And it will go, and maybe say dy minus 0.25. So I'll shift it over and down a little bit. moved it over. Let me do it again. T EX2. Yeah. So you can move things and shift them around. You can also do stuff like this. I could say translate T, and if I didn't know the position exactly, I could say, well, the X value is, so type X on the keyboard. The X value is the end of there, and the Y value is like the center of there. And it's computing the X1793, Y0339. I press enter, and it's moved it to that computed position. So you can do all sorts of special stuff by just typing X and then picking. But let me translate it back to somewhere sensible. Translate. I'll just move it to, let me point at that. That's fine. All right. So once you've got the thing in the right place, you can just press the enter key, and then you just say yes to this, and you pick the base. So the base is separate from the rest, and that's the reason we have that, is so you can figure out how much of a tower, how big the tower needs to be to put the clamp on top of. So you can see underneath there's some dotted lines. That's going to make a little clamp tower for that particular clamp. If I hide the boundaries, you probably see it a little clearer. So you repeat that as many times as you like. You can also make a clamp top plate, as long as it's flat and not at an angle, like tilted up in the air. As long as it's planar in XY, you can make a clamped top plate. You can also duplicate them, reposition them, make an array of them. You know, I had a customer who had a propeller, so he did one at 30 degrees, and he made another 5, copies of it, and he just rotated it around to do that. You've got clamp hole options. This lets you, one time only, you can digitize the center of each of these holes, and it will remember that for that solid model, and it will basically automatically put the holes in the top plate and in the base plate. It will basically cut some holes in the base plate and in the top plate of the clamp tower, so you could run some threaded bar or something down through there, or thread it. So this just makes lets you make a whole scheme automatically. With the car lane stuff, I automatically know those positions, so it will do it automatically. This is just for people who are using some other brand. So that's how that works. Pretty simple. This option is a pre-development thing that is going to be, I'm hoping to complete for the beginning of next year. That's the plan. It's a way of doing a clamp that goes over the top of the fixture, a fixture that goes over the top of the part. You might have like an assembly inside this box that you can't see it from underneath, you can't fixture it from underneath, but you need to locate something, accurately inside of it. This creates a kind of funny hybrid clamp that goes over the top of the fixture and sits on 2 towers, which you remove. So you put your pieces in the box, adjust this over the top onto 2 matching towers, and it keeps it located, so you can spot weld that or get that welded on there too. So that's a new feature that's coming along. So top side fixture. So a fixture on the bottom and a fixture on the top.
All right.
Yeah. This one is, if you draw the welds inside the part, in the CAD drawing, it can pick those names up if they've got a consistent name. They've got the weld body in them or something. And it can check to see if your blades are too close to your welds, so you don't weld the part to the fixture. But it does mean, of course, that they've been drawn, and I've only seen it in about 1% of the drawings I've ever seen have got the welds drawn in anyway. But that's what it's for. In the future, we're hoping to also be able to specify the weld positions, so that we can then send that stuff along with the fixture and the model and the part to our other software called Eureka, where we could do the offline programming. So it's something that also maybe we'll add to this page as an option. Offline programming, kinematics, checking and all that. This page lets you offset the fixture by 10,000, so you've got some part clearance. You can also put these gripper points on it, so every inch to a 50 thousandths radius. It just means that the part's sitting on the bumps versus the edge of the blade, so maybe you've got less friction, you've got some way of adjusting the fixture of the part isn't exactly the same as a computer model, which it never is. So you can do these. They're good for ventilation, good for friction, reduce heat tolerance, heat build up in the fixture. You can do those you want. but it does it across every single blade. What the change in the future will be is that you'll be able to do them just on one blade or just in certain areas of a blade before you build the fixture. Right now you can do them across every blade, or you can just do them at the end of the fixture generation using those direct edit functions. You can just put them on in certain areas, but we're changing it so you can do them kind of more upstream versus downstream. This will actually do it on every blade, as I say, if I check that option. Other than that, pretty simple stuff. Remove small elements that your laser can't process, like normally 1/4 mm or less. They can sometimes struggle with. So pretty easy stuff. This is the weight reduction. So if I want to put holes in the blades, it will try its best to do that. It'll throw away ones that are under a certain minimum area. So you can do that, and you can also do it in the base plate if you want to put holes in the base plate, especially useful if you're turning it over. If it's welded up and you want to get on the rotary axis or the headstock, you might want to have it try to put some holes in there. But you can always put your own holes in after the fact. At the end, you will say, okay, cut me a hole out here, but this is automatic. It's also helpful for ventilation again, so the fixture doesn't get so hot during the day, and obviously the weight of the thing too, so it's not too heavy. This is just the corner reliefs, so Mickey Mouse ears, as I call them, in the corners. You can create them if you don't want to do that. You feel you've got enough clearance in the slot width, you can just remove those. Or if you've got a plasma that doesn't do a very good job on them, or maybe a Dragger style Dragger style laser, where the head line, sometimes they can get stuck. They can get these little things can hang up the sheet, so you can turn them off. This step, so a lot of time you just go next. This step is just the blade. If you wanted to have a left and a right hand fixture for two discrete mirrored parts, you want to make sure you get a left hand part in the left hand fixture. So what this does, you digitize a shape in the fixture in the part, like if it was a flange, maybe a hole in it, circle, square, whatever, and it produces a tower that pops up through that hole. So you can then, when you put the fixture in, the part in the fixture, does it go through the hole? Yes, I've got the right part in the right fixture. It's the same as a location pin or a pin you may use on a traditional fixture. Of course, it can also be used just to add extra support through a feature. So you can actually, if you had a right part, you could just have a fixture that only has these in, and you don't bother drawing any other blades, which that might be necessary or useful, for instance, for a painting fixture. You can imagine it being holding the part up in the air, just up through some features, and you can get your spray gun around it. So it's got many options really. There's just two types. There's one for a big hole and one for a smaller hole. This one's got theoretically 8 points of contact. And this one's got 4 points of contact on this side, to this side, to that side, and you can reverse the direction so it's kind of vertical or horizontal, but just two different flavors basically. Bolt holes. This is where the bolt holes go in the base plate. So you've got your OTC, you've got capital cell. There'd be 3-inch intervals. Just make them the 1/2-inch holes. You can tell it to do it across the whole base plate or the corners on the edges, or don't bother. Or you can also create them, use it to find positions. You just pick them or type them in, and then it will put them there every time if you check the checkbox to say so. That's for rotary, for a head and tail stock situation. You might have these holes on a picture frame, at certain intervals. You need to just type them in one time.
All right.
We're almost there. This is the the clever bit, which no one appreciates. This is what I sweat over, but it's the colours and the translucency. There's a myriad of options here that you don't generally have to tinker with. But the main thing is the rough scan step, the refinement factor, and the line art tolerance. Now, what it does, how it works, if you look at this picture, this is Z+. If it goes along the line, the purple or green line, and it looks in this case, every 30,000ths of an inch, it takes a plot, it plots a point. It says, oh, I've hit the solid, I can see the solid, it plots a point. it looks to the left and the right of the line thickness, of the blade thickness, in about 5 places, and it chooses the lowest point. And it throws away any of the higher ones. So on a given line, it will choose 1 point at each position that's the lowest. And then what it does, it goes round, and in the corners, when it thinks it's detected a corner, it goes and looks in that corner at this factor finer. So in this case, it will go back it will back up 30 thousandths, and then for the next 60 thousandths, it will look 100 times, well, 50 times finer, at 6/10 of a thousandth of an inch in this case. So it's just basically rough scan, then something in the corners. How it knows where there's a corner is done by this minimum angle to determine a corner. So if you ever find that you'll get an interference between the part and the fixture, it might be there's a long gradual radius there. What you can do is make that 10 degrees, and then that kind of problem will disappear. So it has to determine the angle, change in direction over a certain amount of lines and arcs. So you can change that option. So really, and then the line arc reduction tolerance just helps with, if you're getting some funny wacky loops in the geometry, you can change that to like 10 thousandths or 5 thousandths and see if it resolves your problem. But the information, more info, explains how this works, so you get an idea of what it does. Other than that, we've got tubes component scan. If it was a tube part, you can actually tell it to look for radiuses, which is minimum arc length to apply offset triangle. So what it does, if it sees an arc or a bunch of arcs, it could be one arc, and they're over 1 inch, equal to 1 inch, or greater than 1 inch, it will go back, it will offset that arc by this value, which is 0.2 in this case. So it'll make the arc 0.2 inches oversized, and then at 1/3 along the way of the arc and 2/3 along the length of the arc, it will make a little triangle. So the tube's sitting on the triangle, not on the edge of the blade. Right. So if your tube stock changes a little bit, you can just get it to sit on the 2 points versus the periphery, right? So it's a way of adjusting for slightly varying tube stock, right? The other two, yeah, there's some extra things to help with other problems. The exhaustive geometry tech you won't have. I only put it in last week, but it's a way, if you get some funky geometry or some funky results, this will help fix it. What I might do, if you're agreeable, I can give you some beta software to try out, and but it's pretty reliable. I just wanted to, but I haven't put it in the main release yet. But it's it just does some extra checks if necessary to get you around the issues.
Okay.
And then,
we'll see about checking it out.
Yeah. The next step is the final step. I'm going to go back a few pages. I missed one I want to tell you about. Maybe I missed it. Must be getting old. Right. Okay. There's an option called create they're called create storage clips. I didn't see it. But there's an option that says create storage clips. It just makes these two little Pac-Men that you can just cut them, and they will wrap. If you were to stack all the purple ones on top of each other, they would kind of fit around that stacked pile of blades. It's just a way of keeping everything stored together. If you don't decide to spot weld it, you can actually use that option just to make some little clamps basically to keep the stuff all nice together and tight on the shelf. So I can't. I mean, most people turn it off. For the life of me, I can't see where it is. I must be losing my mind. All right. I know where I
All
think.
right.
All right, so let's
Let's
go back to where we were. Um, okay, so I can then say next. This is the annotation. So I could actually put the part number in here, part ABC. If you click this thing here, you can actually put your own logo. You can design your own logo one time if you want. Like I've got one here for, lots of people, Lincoln Electric, for instance. You'll just put basically the Lincoln Electric logo on the base plate. Obvious things like how far away from the edge, font size. This step check is quite useful. If you've got a very big part which has got lots of real estate, as it were, on the blade to place the text, like the annotation, so it says this is U1, this is U2, you can use a bigger number here. It just means when it's set to 1, check step is 1, it means if you have the letter A, it will look at, like, on the left hand side of the blade, it will say what's the width of letter A, can I fit it on the blade without it interfering with one of the slots from say the green blade. And it keeps looking, and it just steps the distance of the letter A width along the blade, so it could be, if it was a half-inch wide A and it's 100 inches long, it's going to do 200 checks to see whether it can fit that letter A there. If you think I've got lots of real estate and lots of space, you can check that, set it to 4 or 6 or something. If it's a small fixture and there's lots of blades intersecting, you might need a 1 or a 0.5, so it can make more checks to see if it can fit the text on there. So it's just a kind of factor to adjust how often it checks for placing the text on the blades, because it has to put them in an intelligent place, because they're optionally cut through. They're a stencil font that cut through the blade, so you don't want to obviously put them where there's an intersecting blade going the opposite direction. You can change the position where you want them, left, middle, or right, or on a tab. The tab is like this kind of bump speech bubble at the side here. If you want, you can do that. You can also put them on the base plate as well as on the on the blade itself. And then the base plate legend is just this thing. You can turn this off. It just tells you which is X, which is Y, and how many in X and how many in Y. So you can turn that off. This annotate duplicates of alpha references. If you check that, it will look for blades that are identical. And if they're identical, instead of calling them U1, U2, U3, U4, it may have U1, UA, U3, U4. UA basically is 2 of them. It'll tell you to cut 2 of them, and you'll have 2 references on the base plate for a position UA. And maybe for the other direction blades, when they're N direction, you might have NA, NB, and NC, they're duplicated. So it's just a way of doing it, finding duplicates and referencing them, and telling them how many you want to cut of that particular one. Most of the other things you don't change here. Ah, there it is. It was on the last page. I knew. I'll show you what that does, and then maybe it makes sense. Create storage clips. Right. So once you're there, you're ready to go. You can do a preview, which is quicker, but as I said before, don't guarantee it's going to be correct, because it's not doing what it's not doing. In essence, is this clever stuff. It's not doing the fine stuff. It's just doing a rough scan. It's not putting the feet in there, but we can do it. But I'm not going to bother. It's a small fixture. It's not going to take long. You can go back to any of those steps and change any of those values. And be honest, if you open this file in the future, you save it and open it, the Nucleo editor is basically this. This is what you comes up with, so you can go back to any of those steps and change any of the values. So I can then say build the fixture. I'm going to just build it. Okay. So when it's adding the cutout text, this is when it can, if you've got a really big fixture and you've got a small step, it will take longer. So that's why I say to massage that. based on the type of part you're looking at. It's not almost there.
Almost.
Yeah. It's a little slow on GoToMeeting. It slows it down somewhat too. Right. So see the Pac-Man that turned up. These are the storage clips. All right. So
All right.
you were to stack all the purple ones for the ends. That will all the ends, which are the green ones. 1, 2, 3, 4, 5. That distance is 5 widths of that material. Then you've got probably the same 5 for the other direction. So you just cut as many of those as you like. And if you're keeping this thing stored on a shelf in a flat pack form, you can just use it to clip them together. In a flat form, like an IKEA stuff comes in. So you see, I've got my logo and that on there. If I repaint the screen to get rid of those hexagons, you can see it better. Then we've got the ability. You can see each of the etchings. If I can hide the part, maybe you can see. I've got a UC, so I've got some here that are identical. Actually, a lot of them. These are identical. So it hasn't actually used 1, 2, or 3. It's using alpha references. It means that there's a lot of identical ones here. So you can see which one goes where. Put the part back in. When it built it, it gave me a report of what's going on. So it tells me if there's any problems. It's told me that it's removed some small spans, which I told it to. I told it to remove anything under 10,000ths of an inch. So it's removed those from the fixture. So you just have to check there's no problems there. If I go to an XZ view, you can see the overside. Repaint the screen. You can see the clearance. Yeah. Then if you look at the feet, you can see my locking mechanism. My feet go in, so they would, they go in a slot. They interlock.
All right, that's the base plate.
Into the base plate, yeah. So if you didn't want that, you just wanted to be flat, you also would remove this parameter and just make the depth of the thing only 1196. Or say if you had a 1/4 inch base plate, you would put 0.25 in, right? Because in this case, we're going to have to put this up on some bushings. You'd have to put some bushings on the table just to offset it from the surface of the table. Right? So once you've got this done, you're done. You could export the CAD system, export the CAD files. I'll do it for the sake of arguing. It's colouring in different things, based on the size of the geometry. It will choose a colour to assign.
And to get that, you clicked on the build, CAD export build, right?
That's why I just said export CAD. But you could, if you come out of the dialog already, if I had said done, I could just go to that button up there and do it. It's the same thing. All right. If you want to rebuild the fixture, you don't have to come into the editor at all. You can just go straight to build. But you can also do it in here, right? So in the end, you end up with a report, which I'll open for you. Just write something down. Okay. So I'll say yes. Show me it. Show me the files. So I've told it I want a STL of each piece. Of an STL. So you can give that to anybody who's got Windows 10, or there's free software you can do just to view a rough, a rough version of it. That's the part, and obviously that's a fixture, and you've got one of the part. The reason they're in two models is because you cannot assign colors to STL. So if you bring it into some other software, you could at least make the box green and the rest, gold or something, so you can see it. Which is useful when I talked about the robot software. That's what we would take into the robot software, would be a STL file. There's also the Parasolid, if you want to take that back into a CAD system. And then you have each individual DXF. I use this JetCam viewer. It's free. It's really neat. You can just open it up and you can just see them very quickly in each. This is a kind of explorer view, so you can get this from jetcam.com. And then you've got, pictures of it. As long as your antivirus doesn't block it, you'll get some pictures. Okay, and then you've also got your material report. So we've got two of these. Got two with one of those. There's two of those, three of those, one of those. So you can see how many quantities, and it gives you the area and the perimeter of each one, and the cumulative area and perimeter, and the estimated fixture weight. Okay.
All right.
Not sure what this is.
And now, if I wanted to send this to the laser, would I send him all the DXF files?
Yes. Yeah.
Right.
It puts it all in a folder under the name of the, puts it under a folder box, and then, so you just take all those. Right. So, so yeah, I say done. I'm done. I could rebuild it from here. I could just export the CAD files from here. It's the same thing as using the editor, just shortcut.
Or we can make changes to it.
Sorry?
Or we can make changes to it.
Yeah, if we wanted to go back to it, we could go back in the editor and change something and rebuild it, right?
Okay.
So we wanted to make the feet not like that. We could just we could go to the blade tab parameters and say, okay, we don't put the picture on. We don't want a width here. We just want it to be 1196. And then when we rebuild it, we just get rectangles in the base plate, right?
Okay.
Right. What you can do though after the fact is you can direct edit it. I'll show you that. So direct edit, and then it says pick the solid body. I'll pick this one because you can see it easier. And I can do stuff like, remove this line. I can then draw with line art, draw something done. So I'm in automatic snap mode, end of, arc mode, A for arc.
Okay.
Right. Make sure my geometry is closed, and if I go fixture, end, direct edit, end.
Okay.
Yeah, I got that in there then, and then I could export that again to my CAD system. I could just go export it, and it'll have that in it. I think you can also, from memory, I think you can also do like, I could draw a full arc and maybe. Make it a 2-inch radius. Well, that's too big. Undo that. Full arc, 1-inch radius. Yeah. You can do stuff like that.
Oh, okay.
You can also do. I had trouble with this on my machine. Let's just make sure it works today. So I had trouble with it a minute ago. This is my copy though. You can do what I talked about, these grippers. You can do in certain points. Let's just try it. Add. So I'm saying 50,000th gripper every inch. And I'm going to say select the start here. So from about here to about here, put me these bumps in there. So I'll commit those. Click OK. Update the assembly. Yeah, it did work okay. I've now got I've got those bumps in there, so you can see where they can be used just in zones. if you want.
Yeah.
And then the other option is add a child detail, which is the same as what I just did with that circle, to be honest. I just did it another way. You can select the base, the blade, and then you can just say, okay, give me a rectangle, and then create the feature. It's got a snap mode on it, like 1/4 inch snaps by the look of it, no, 0.2 inch. And then I can say update the fixture. Yeah, so you can do the same way, but doing the thing with the circle really. Again, this kind of thing you do at the end when you're really happy with it, and then you can re-export it and build it, build the CAD exports, and you're back to the beginning. So you save the file. Yeah, if you came back tomorrow, you just open that file up, and you start basically go back to the editor and change any of the particular things you need. So again, I said the visibility just lets you hide things, hide the fixture, hide the part, show the fixture, clamps, don't want the clamps, you can see the top plate.
Well, I was playing with the software all day yesterday and some this morning, and I was almost there.
That's good. There's some things you can't grasp over that. I mean, that's why I have to show you some of the, features.
Yeah.
Hopefully it's a bit clearer when you've got.
Oh yeah, it is. It is definitely a lot clearer now.
Now, the one thing I will show you I'll show you one. I talked about those custom boundaries where you might use line art draw. I'll show you quickly that as a quick, so you can maybe grasp it. Say if I hide my boundaries and I hide my fixture. So say I wanted to, for some reason, have a nice, like a kind of draped edge on the edge of this, right? What I could do is if I go to the X Z view, I've got this is the, no, I want to go to the YZ view, right? I can push, there's some buttons down here, X, Y, Y, Z, X, Z, Y, Z. So it's a plane you want to draw in. So I'm going to draw in the YZ plane. So push that in. Then I can just say draw a line arc. So I'm going to say, okay, I'm starting outside my lines, somewhere outside. I'm going to go like this. I'm going to do a nice, nice smoothie. I'll just do line to here, for instance. Doesn't really matter. So I've created that section, right? And then I come out of the command, press escape. I go back to XY. I have to go back to XY. That's important. I now got that drawn. I can then say edit. No, it's modify. It's draw. Sorry, it's draw. Extrude. And I say this is a profile. I want to extrude. So I want to click this. I can just link it. So I could just get my mouse over it, right click, and say linked. It gets them all. All right. Press the enter key. Press the green check. And it's created me this section, right? But I want it to go basically, say 6. Let's look at 0. Let's go 20. Just be negative there. Yeah, minus 20. It depends on the way you pick it, which way it thinks positive and negative. That's okay. So maybe I could go 10. So it kind of, as long as it fits over my lines, right? It's a bit, I'm going to go 12. So now I've created a custom boundary that's kind of going to be like that. I can then go in here and I can, make it, change its material, make it a little bit less transparent, I mean more transparent, steel or something. Right. And then the only thing I have to do then to use that is you could just build the fixture. What I'm going to do though is it's just a sheet body right now. It's not a solid body. The icon's different. So to make it a regular boundary, I just got to make it into a sheet body. The quickest way to do that is to edit 3D and just thicken it, give it a little bit of thickness. So I pick that sheet, and I'm going to say it's, I don't know, 0.1 millimeters. If you want to type in millimeters in an inch program, you just type in mm. If you want to type in an inch value in a metric program, you type in, inch mark. So this is going to, I'm actually making it 1 millimeter equivalent in inches now, thicker, and then 0 for the inside. So now it's thickened it up. It's got a little bit of thickness to it. Can't really see it, but it is there. And then I can just tell the software that that's now a boundary, so it knows to turn it on and off. I just say assign it as a boundary. So pick it, press enter, and then it's gone now because the fixture the boundary layer was off. It disappeared, right? So I could then tell it, instead of using this envelope boundary, if I turn it back on again, I could delete this boundary. So now it's going to stop at this, where it finds an intersection on this part, right? So you can get into advanced things like that. There are things on the internet, on our website that explains that again.
Right.
It's just a way to, if you want to do something specifically clever, you can do that.
There's just other ways to do it.
It's another way to do a custom 3D shaped boundary, because for ease of use in the software, they're just flat ones, but you might want a nice curved one. You can build up the same effect by putting multiple boundaries on there and tilting them, of course. But this is just another way to skin the cat. I just wanted to show you that these kind of things exist if you wanted to ever get into it. If you want to follow the general shape of the thick part, say it was like a grab, like a some kind of grabber that you see on a in a scrapyard, you're making something like that. You might want to make it a little follow the curvature of the hook on the end of it, really. So it's almost finished. You see, it's made it like that shape now.
All right. That could come in handy someday.
Yeah, I just want to make you aware of it. That if you wanted to form it to a given shape, you just draw a boundary that you might be, you can do it in your other CAD system if you wanted to before you bring it in, but you can do it here too.
Yeah. All right.
So, I mean, that's everything in a nutshell from A to Z, how it works. It's relatively easy, I think, once you've got I've recorded this video, so I can put it on the web and you can always look at it again.
All right, I appreciate that. Yeah, send a link to it to Gary's email.
Yeah, it'll take a while to build it, convert it, but I will do that. I'll send a link to it, and you got this as a reference, right? I think the first thing is go away and try your first one, and if you get trouble, just drop us an email with your CAD drawing. Always include your attempt, your VDM file, the file it makes.
Okay.
And then we can we can get back in touch and tell you how to do it. Because obviously sometimes there's a few, you don't know everything off the bat when you new software.
Yeah.
That's it really. So, have you got any other questions right now?
Hold on. All right. No, I didn't have no questions, and the question that was asked, our laser man's figured it out already. So
Okay.
For now, if I have any questions, I'll have Gary email you. And
Yeah. Email me or email support line. There's a support email address, but you can, if it doesn't matter, you can email me and I'll forward it on. It's just if it goes straight to me and I'm out of the office, it's better to get it to there's a support. I think it should have had some information from other people who contacted you, maybe Lynn. There's a support at optisolutionsUSA.com is the email address, but just don't.
All right, I'm information.
Okay.
I appreciate it, Rob.
Okay. Well, you get any questions, be in touch and I'll speak to you soon.
All right. Thank you, Rob. You have a good day.
Yes, you too. Bye-bye.